Okay, so in this example, we are going to focus on the angle made by a line. So because a line is slanted, so you will make an angle with the horizontal axis. Okay, so there is some amount of trigo in this idea. Okay, so maybe you may have some missing idea at the moment because you haven't learned enough trigo. So currently, some of you, your trigo is at the Sec 2 idea. So maybe it seems a bit difficult. Okay, so I try to simplify as best as I can. Okay, when you actually learn more trigo, right, it will be easier. Okay, so I'm going to show you the idea on, so I have this line L1 here. Okay, so can see this is L1. Okay, so on this line, I'm trying to get 2 points. So I'm trying to get 2 coordinates so that I can get the gradient. Okay, so the angle that it makes with the axis, right, is dependent on the gradient. If it's a very steep line, obviously the angle will be very big. So that's why I need to show you how gradient is related to the angle. So in this question, right, I'm just going to get 2 lines on the 2 points on the blue line. So I'm just going to get 2 points on the blue line, and I'm going to calculate the gradient. So go for your calculation of gradient. Try not to make careless mistake. So in this case, my okay, hang on now. So the gradient is 2. Okay, so in this case, the gradient is 2. Okay, and then right, okay, I'm going to draw a right angle triangle to show you. Okay, so I'm going to call this triangle AOB. So for those of you, if you still remember, in a triangle, this angle is θ1. Okay, so if I use the triangle, I can do a tangent theta. If I do a tangent theta, it's the opposite over the adjacent. So it's like the length. So it will be 6/3, which is equal to 2. So if you realize the gradient is equal to 2, the tangent theta is also equal to 2. So that's why your teacher will have shown you this formula. So that is the formula. M is equal to, so in this case, M1 is equal to tangent theta. That means, right, the gradient actually affect the angle. Okay, so that is how actually we come up with a formula. So in this case, this is for a positive gradient. Okay, so I'm going to go to the other line where it is a negative gradient. So for negative gradient, right, the angle is obtuse. The angle is obtuse if the gradient is negative. So this one is line 2. So for line 2, again, I'm going to get 2 points. So the 2 points will be 0, 2, and 6, 0. So do your calculation for gradient. So you will get 1/3. So you will get minus 1/3. You should be expecting a negative gradient because the line is coming down. Okay, again, I'm going to introduce you the right angle triangle here. So I'm going to show you the right angle triangle. So for the right angle triangle, okay, so this angle is not θ2. This angle here is 180 minus θ2. So I can do a tangent of that angle. Okay, so if you start on some trigo, you will learn this part. Okay, so if I do a tangent, it will be the opposite over the adjacent, which is 2 units over 6 units. So that is 1/3. So that is 1/3. So you realize that now there's a difference between the two. One is a negative and one is a positive. Okay, so from here, because of some trigo knowledge that I'm not able to explain here, so from here, I will know that tangent theta 2 is actually equal to negative 1/3. So this part is the acute angle. Acute angle will have positive ratio. So this is the obtuse angle. Obtuse angle will have a negative ratio. At this moment, right, you may not understand why negative angle has a negative ratio. So you need to accept this fact first. When you go to the trigo, EMATH trigo, you will learn this, that tangent obtuse is always a negative ratio. So because of this, then the gradient will match. Then you find that this and this will match. And that leads you to M2 equal to tangent theta 2. So if the gradient is negative, the angle that is made is obtuse angle. So all in all, if you have negative gradient, the angle is an obtuse angle. Okay. If you got positive gradient, the angle is a positive value. Okay, so I think to better illustrate this, I will show you the numerical value in the practice question. Okay, so at this moment, right, you just need to know that if gradient is positive, the angle is acute. If the gradient is negative, the angle is obtuse. Okay, so I think it's easier if I show you on the example here. So I'm supposed to find the angle that the line make with the axis. Okay, so bear in mind just now what I say. If the gradient is positive, the angle is acute. If the gradient is negative, the angle is obtuse. So I'm going to calculate my gradient first. So if I calculate my gradient, I got a positive gradient 5. So it is a positive gradient. So I'm expecting the angle to be acute angle. So you can do a direct tangent inverse 5. So you can do a direct tangent inverse 5, you'll get an acute angle. Okay, let's try the next one. So if you work out the next one, you will get a negative gradient. So you will get a negative 1.5. So if it's a negative 1.5, okay, so tangent theta, okay, I will ignore the negative first. I will try to get the acute angle first. So in order to get the acute angle, I will ignore the negative. Then the angle made by the line, because in this case it's a negative gradient, then you will just do 180 minus 56.3. So you will get 123.7. So currently you'll find this a bit confusing. Subsequently, when you go for EMATH trigo or AMATH trigo, every time we will want to solve angle, right, we will ignore the sign first. So in this case, I'm ignoring the sign, I get my acute angle, and I can find the comparative obtuse angle. So if it's a negative gradient, the angle is obtuse. If it's a positive gradient, the angle is acute. Acute means it's less than 90 degrees. Okay, so this is one of the part that involve a little bit on trigo. Okay, and there are some questions, some long questions that have this idea. Okay, so we'll see the long questions regarding this in the next teaching.